Okay, so let's continue. I think we stop here in showing that B-perp is a subspace and B mode W is a subspace. So let's start with a new concept now. The projection of V and to the projection of Y and to V. Okay, so definition 2.8, let Y be a vector. This is n by 1 and V a subspace of R to the n. So a projection. So note that the subspace V is the same as the vector in that. Sometimes it's we let Y be just an RP or a P by 1 wherein P is less than N. No? So in this case, we have a subspace Rn. We have also a vector in Rn. So a projection of Y onto V, which is usually you see this notation later, the projection of Y onto V is a vector V. So your V is equal to the projection of Y onto V if these two conditions are satisfied. First, V should be in your subspace V and Y minus V will be at B-perp. B-perp is the subspace or orthogonal to V or perpendicular to V. So in geometric interpretation here, sometimes you can write it here. Say if you have a vector Y here and you have a space here, V, the projection of Y onto V is here. This is the projection of Y onto V, and this is in V. And Y minus, if this is small v, then Y minus small v is the one which is orthogonal to the projection of Y onto V. So this is your subspace V. So sao man na pag-drawing ha, basta ang space din perpendicular ani na papel din na V, this is your B-perp. Okay? Good. Equivalently, so equivalent V is a projection of Y onto V if V is in V and V minus V is orthogonal to V, or this is in B-perp. Note that V, a point in V that is closest to Y. So kung naa kay Y din katong din that will be the closest, that will be the projection, the one that will form a right angle there. Okay, so any other point will not be the closest. So kung kini imong point, dili na siya ang closest. Dili na siya ang closest. Kung kini imong point, dili na siya ang closest. Okay. So theorem 2.4 of Arnold's says that if we have a subspace V in Rn and we let a vector Y in Rn, then the following statements are equivalent. So how many statements do we have? We have 3. So if it is equivalent, then equivalent statement na kay P, Q, ug R na statement. So P equivalent if and only if Q na siya. Q if and only if R, and P if and only if R. So if we have an if and only if statement, equivalent statement, ibig sabihin, when we try to prove it, we have P if and only if Q, Q if and only if R, and P if and only if R. So you will have 6. No, P implies Q, Q implies P, Q implies R implies Q, P implies R, and R implies P for it to be equivalent. Okay, so what are these equivalent statements? So there exists a projection. There exists a projection of Y onto V. The projection is unique. So in other words, if we want A if and only if B, so if there exists a projection of Y onto V, then the projection is unique. If the projection is the other way around, if the projection is unique, there exists a projection of Y onto V. No? And the third statement is, if X is a basis matrix for V. Again, what is the definition of a basis matrix? The vectors that forms the basis, the matrix X, are linearly independent and they span V. No? If X is a basis matrix for V, then the projection of Y onto V is given by this formula. So this statement C is telling you that the projection of Y onto V, and if you have a basis matrix X that is equal to X, X prime X inverse X prime Y. That's the projection of Y onto V on this, ano. And then if we relate it to statement A and B, so if you have a basis matrix and the projection is X prime X inverse X prime Y, then it means that this projection is unique. Of course, there exists a projection. So in the 6 statements that we have, A, B, and C, A if and only if B, B if and only if C, A if and only if C, some relation there are clear, no? It is clear. So, unsa man ang clear na statements? Ang clear na statements daw is A if and only if C, and B if and only if C. So, what we want to show only is that A if and only if B, no? Mao na lang na atong i-show. So what is A if and only if C? So there exists a projection of Y on B. There exists a projection of Y on B. Man ang C kay naa kay projection and it is given by that. So klaro ni siyang A if and only if C. Kung naa kay projection, then CA, there exists a projection on V. So this is clear. Muna siya, ingon siya clearly. And another clear daw is the projection is unique. So this is a basis matrix. This is unique. Why? Why is this unique? Because we have shown that X prime X is invertible. And then it has a vertex, vertex inverse. This inverse is unique. So this projection will also be unique. So this is a clear statement. So ang ato na lang i-prove is the A if and only if B. Okay, so this is the proof of the A if and only if B. So A implies B. So unsa gani ng A implies B? Suppose A and then show B. Ito ganitong ano, A. There exists a projection. So suppose there exists a projection of y unto V. Now you have to show that this projection is unique. To show uniqueness, you assign two different values of projections. So in your proof, you assume or you let two projections. So let U and V be projections of Y unto V. To show uniqueness, you have to show that U is equal to V. That is showing uniqueness. Okay. So if U and V are projections of Y and to V, then by definition of projection, both U and V are in the subspace V, and Y minus U and Y minus V is in B perp. That is by definition of projection. Now, since V is a subspace, sa ganitong subspace, ang subspace is closed under taking the linear combination. So if both U and B are in V, then U minus B, which is a linear combination of vectors in V, are also in V. Are you following? So V is a subspace. Pag subspace gani, any linear combinations of the vectors is also in that space. It's closed. So U minus B is also in V. Also, B perp is a subspace. We have shown. So all vectors in B perp, when you take the linear combination of that, it's also in B perp. So if you consider Y minus B minus Y minus U, which is Y minus B plus U minus Y, which is actually U minus B, is in B perp. So we have shown that kini, U minus B is in V. Also, U minus B is in B perp. So unsa may pasabot ana? When one vector is in V and the other one is in B perp, when you get the inner product, it is equal to 0. Correct? So if it is equal to 0, the inner product is equal to 0. A square equal to 0. So either A is 0 or A is 0. So it means that A is 0. Diba? A, B equal to 0 means that A, B equal to 0 means A is 0 or B is 0. So ato din A square lang. So it means that U minus B is 0, meaning U is equal to V. And then we have shown that the uniqueness of your two projections here. That is, U is just equal to V. Therefore, the projection is unique. Okay. Now, let's do the other way around. Let's suppose that the projection is unique or V is unique. So if it is unique, let us assume that that unique vector is x prime x inverse x prime y. Or you can write it in that manner where x is a basis matrix for V and Y is in RP. So by lemma 2.2b, sa may lemma 2.2b. Lemma 2.2b tells you that a vector V is in V if and only if you can write it. So, giingon din lemma 2.2b. One. V is in V if and only if V can be written as XB. Okay? For some B in RP. Or so. If we let this, okay, this is Rn, no? Equivalently, if this is Rn. If this is Rn, and Y is Rn, you have an X. So, ibig sabihin, if this is how we define our projection V, we can have what? So, kung P by 1 ni siya, dapat ang imong X P by P. Okay. This is P by P. This is P by P. Okay, so P by P na tanan. Okay. So, ingon diha sa lemma 2.2b, kung itsura daw nimo imong vector as XB for some vector RP, or in our particular theorem, Y is in Rn, then we can conclude that V is in V. So this is the conclusion using that. Since we have written the vector in this, or the projection in this manner, then we conclude that this projection is in V. Okay. So if, again, by lemma 2.2b, if we have another vector U in V, we can always transform that in XC for some C in CP. Or in this example, ay dapat Rn na siya. And X is a basis matrix. So pwede nimo isulat ani. So CU nasa V. Si V nasa V. Okay? Para mahimo ning projection, sa ganitong definition sa projection, dapat CU, si V, para mahimo niya siyang projection, dapat si V nasa B, man si Y minus V nasa B per. So arbitrarily, mamili ta og another vector in V. Mankuhaon nato ang inner product sa Y minus V and U. So gusto nato na kini siya nasa B perp, man kini nasa B. So ang atong aim equal to 0 na siya para mahimo ni siyang nasa B perp. Okay, so let's look at this Y minus V and U. Okay, Y minus, how you define V and U. So by definition of UV inner product, this is equal to U prime V. So you have U prime V. And then get the prime, Y prime, A minus B, or A plus or minus B prime, that is equal to A prime plus minus B prime. That's properties of primes or transpose for linear functions. And then if you have A, B, C prime, you have C prime, B prime, A prime. So applying it here, the prime of this, are you with me?
Yes, ma'am. Yes, ma'am.
Applying the primes here. So you have Y prime, man kini, X, okay? A prime inverse, A inverse prime is just equal to A in prime inverse. So as is ni siya. Pero tungod kay X prime X man na, kuhaon nimo ang prime ana X prime X gihapon. Di ba? Correct? Because x prime prime is just x. So may tabuan eh, x prime x prime is just x prime prime, which is x. X prime x ra gyapon siya. So x prime is just x prime x. And then this one is x prime. So nakuha ba to? C. ABC prime is C prime, B prime, A prime. A inverse prime is just equal to A prime inverse. Nasa pa ba? Okay. A plus minus B prime is A prime plus minus B prime. Okay? So, kana ang mga properties sa primes? So, okay na ta dinhi. Okay na ta diha. And then, ang atong gibuhat is sulod na din ha. So, you have this. Okay. But x prime x invertible means, sa kani ang x prime x invertible, meaning x prime x inverse exists and x prime x inverse is just the identity matrix. So this part here is your identity matrix, which leads you to this equation. And that is 0. So what is the meaning of that? When we got I want to change color. Okay, when we get the inner product of this, when we got the inner product of that, and we know that U is in B and the inner product is 0, this will imply that U minus B is in B perp. Okay, so what do you want to show? We want to show that there exists a projection. B implies A. So A, we want to show that there exists a projection. So duwa ang imong ipakita na basta projection. You want B to be in B and Y minus B is in B perp. That is projection. So mo ning ang atong gi-prove din duha. Primero nimong ipakita B is in B is in B. Ang ikaduha B Y minus B in B perp. So since we have shown these two, hence there exists a projection of Y onto V, which is the vector V defined as x prime x inverse x prime y. Okay, so these notations is defined as the projection of Y onto the subspace V. It can also define in other literature as a linear function that assigns Y, each Y its projection on V. Sometimes this notation is also used as matrix for function of the projections. So just take note of the possible meaning of these notations. No? So it can be a projection, it can be a linear function, it can be a matrix. Mo na itawag na abuse of notation. Okay. Okay, so let's see some elementary properties of projections. So if you recall, this is your y. Project it on V. That is your projection of y onto V. And we call this V. This line here is y minus V in V perp. Okay. So if you look at this, this is a triangle, no? Using the Pythagorean theorem. So if B is in V, this is your subspace V here. And always have a space there wherein naadiha ang imuhang projection. Then y minus V, the square length of y minus B, inomdomos Pythagorean, C squared is equal to A squared plus B squared, no? Ang C squared is your murag hypotenuse and then the leg, no? So in here, the square norm of y minus V is equal to y minus the projection of y onto V plus the projection. So ang leg din ang projection, ang y minus the projection of y onto V and the projection of y minus V. So ang gawas ani murag kini ang hypotenuse kana, no? Katumang guni siya vector na space, so pwede na siya i-tilt na that will become the hypotenuse of a triangle. Dili mag-erase. Okay. So let's prove this. Usual assumption, you have y, an n by 1 vector. Your vector v is in, you let a vector be in V and this notation as your projection of y onto V. So, pareha sila. Si projection o si V, pareha sila naa sa V. Sa subspace V. So, this V is not necessarily be the projection, no? This is another vector in V. Okay. Our projection is denoted by this. This is just another vector in V. So kung imo nang i-drawing, kung naani si Y, mao ni imong subspace na V, na kay projection din pero napo kay another vector diha. Natawag nato V. Napo kay vector diha na V. Not necessarily the projection. You have another vector. So, kung kini mong space, pwede ka na kay vector din na V, na po kay vector din na the projection of y onto V. So, what will be the relationship between a vector in V and the projection of y onto V? Okay. So by definitions of projection, this projection is in V, then y minus b is in B perp. That is just using the definition of projection. And another is, since V is a subspace, you can have a linear combination of the vectors in V. So you have this V in V and this projection of y onto V to be another vector in V. And you can always have a linear combination of that. And this is also in V because subspace are closed under linear combinations. Okay. Question? No questions until this, no? Now, this is in B perp. This is in V. So it means that they are orthogonal. So y minus b, y minus the projection of y onto V is orthogonal to the projection of y onto V minus V. So that if you get the inner product of that, that is equal to 0. So either you get this or this, pareha raman na, because the inner product of UV is equal to U prime V or V prime U. No? So either kini mauna, ay ha ni, or kini mauna, ay ha na, still 0. Okay. So klaro na ning mga ano din he, implications. Okay. Next, we want this, so we write that. Okay, so we just add and subtract with this term. Okay, mo man ay naa diha. Add and subtract groupings. Inner product UV is equal to U prime V. So this is your U prime, this is your V. And then application of primes. Application of primes. We have prime, prime. Again, A plus B prime is A prime plus B prime. Asa to sa father po? Zeo. And then here, so okay na ta diha. So what happens from here to here? So this is just distributive property. So you have this. So this is y minus the projection of y onto B prime, y minus the projection of y onto V. That is your square norm. Ang kinipod na part, projection of y onto V minus V prime, projection of y onto V minus V. This is the square norm of the projection of y onto V. And then the middle product na dayon. No? So A plus B, C plus D. Maura na naitabo. AC. Kaya lang, pareha man eh. Okay, pareha si A ug C. AC plus BC plus CB plus AD. Oh. Okay. D squared. Malagi kay AD na. Anyway, that is very easy to you, algebra. Now, we have shown earlier na this part and this part is equal to, sa gani? 0. Ngano gani? Orthogonal na silang duha. So ang inner product nila is 0 by definition of orthogonality. This is just 0. This is 0. So what remains is this one. And to show B that, say, tawag ani. Kini, unsa gani ni? Na kay Y, na kay projection din hi. Kana, unsa gani ni? This is Y minus the projection of Y unto V. Unsay pasabot ani? Kini daw na distance din hi is always less than any difference of Y minus any V in the subspace. So kung naa kay mga vectors din hi, naa kay mga vectors din hi, no? Si ana or kana. Ang distance daw ana kana. Kining pula is always less than or equal, or the square length, no? Is always less than any other competitive na Y minus V. No? Kanang blue. So, unsa may pasabot ana? Kung ano, unsay pasabot ani na statement, kining letter B. Naman ko'y gisulat sa una sa notes na C theorem 2.5B. Unsa to akong gisulat dito? 2.5B. Unsa to na statement akong gibutang dito? Sa notes. Unsay in English ani, in layman's term, naman ko gibutang sa una na note dito na C theorem 2.5B. Unsa to siya? Wala ko estudyante. Asa ako estudyante. Sa akong gisulat. Naman to. Na-out naman siguro ni sila. Wa naman ay nangingog din Unsa to? Ato na ako gisulat.
Ang AB prime, ma'am, is
Katong akong gisulat na ako'y ginote, this is proven in theorem 2.5B. Asa to dapit? Linear notes 1? Nara. Kini. Note that V is a point in V that is closest to Y. So, ibig sabihin, ang projection ang projection, kaya atong notation din sa projection is V. No? So, kini na proof din will show you, will imply na mao man ni atong V. Kaya atong notation sa projection of Y unto V is V sa definition. Pero dinhi na theorem, it's another, kining V din is another vector in V. It's another vector in V. So, kini nagpasabot kung naa kay kompetensya any other vector in V, ang katong projection of Y unto V will be the one closest to your vector Y, no? Because the square length siya ang pinakagamay for all V in V. With equality, when that particular V is your vector, is the projection of Y unto V, equal sila. Okay? So, una gani ipaprove na show that the projection of Y is the vector closest to Y. Ibig sabihin, mauni na proof ang gusto ipakita ninyo na the square norm difference of Y from the projection of Y unto V is always less than the square norm difference of Y and V for all V in your subspace V. Okay, so from here, from A, we have shown that one, which is this one.
I-check yung cellphone kay nag-call siya sa kuan oh. Pwede mo siya on call, i-off.
And then, manipulations will give you this one. So, unsa na itabuan eh. Balihin lang ni. Pabili na siya. Pabili na. Pabilin lang ni. Kana ibalhin. Kaya mamani mong gusto. Okay? Okay. So what is the meaning of this? This square norm to have equality is the difference between this. So that ma-attain ang equality kung kini siya minusan pa nimo ani. So kung mawala ni siya, ibig sabihin kini dako gini compared to that. So kung ipa-prove mo later, show that the projection of Y is the closest, is the point closest to Y, you have to start with this proof here. You have to start with this proof, then continue with this proof. So that is showing closest. Okay? And clearly, if the projection of Y onto V is your vector V, then you attain equality. Okay, next. Prove that if and only if the projection of Y onto V is just your Y, if and only if your Y is in V. So, kato akong ginadrawing. Si Y na agad dinhi. Uman ang projection na dinhi. Pero kinina statement ng ingon, kung kini si Y na dinhi, then kini mismo si Y mao ang projection of Y unto V. Kung naa na siya diha na subspace. So how do you prove that? If and only if man eh. So you suppose that the projection of Y unto V is just Y. By definition of projection, obviously Y is in V. Man na. Okay? Next, suppose Y is in V, then Y minus the projection of Y unto V is in V perp. Okay, since Y is in V, and any linear combination of your Y is in B perp. Now since Y is in V, then Y minus Y is in B perp. By uniqueness of projection, then this Y should be the projection. Okay? So very easy, straightforward proof. Next. If the projection of Y unto V is 0, then this Y is in V perp. So kung ang projection is 0, na siya din sa orthogonal anin na subspace V, no? B perp. Anyway. So how do you prove this? This is if and only if. Assume that the projection of y unto b is 0. Definition of projection, y minus the projection of y unto v, which is just y, is, so y is in B perp. Okay. And then suppose your y is in B perp, then by definition of projection, by equivalence, y minus 0 is also in B perp. This means that your 0 here is in V, but that is the projection of y unto V, because this is by definition of projection. So this is straightforward. So what is this result telling you? Pag ang imuhang y mao na ang projection, then y is in V, or vice versa. Pag ang imuhang projection 0, then si y na sa B perp. Or kung si y na sa B perp, ang projection 0. Next. Okay, unsa may projection sa y sa B perp? By definition, di ba? Mao na si y minus B perp. Projection. If this is y, this is the projection of y unto V in your space V. Ang y minus the projection of y unto V is actually the projection on B perp. No? Nasya din sa B perp nimo. That is the projection of y sa B perp. So kung kini mong y, ang projection niya sa B perp is y minus the projection of y unto B perp. Okay, how do you show that? Sa kay projection man eh. So by definition of projection, ang sa atong gusto ipakita ani. If this is a projection, then we have to verify if this is a projection, so the projection of y unto B perp is y minus the projection of y unto B. We have to verify that y minus is in V perp. And then ang isa, y minus PBY minus the projection of y unto B perp is an element of B perp perp. But B perp perp is V. Okay? Ang projection man eh. Mali ko din eh. This vector is in B perp, and y minus this vector, projection of y unto B perp, is in B perp perp, or just an element of V. But this by definition is y minus B perp y. So dapat na siya sa B. So mo ni ipakita nimo o kana. So obviously, kini siya, the projection of y unto V is an element of V. So y minus an element of B is in B perp by definition of projection. So this shows 1. And this one, after simplification, gives you the projection of y onto v, which is an element of v. So, done. Very easy. So, if we let v be the projection of y onto v, basta ang projection of y onto v, nagi na siya sa space na v din eh. So, by definition of projection, y minus v, that is in v perp, which is what we want to show. And then here, simplification, cancellation of vectors, this is in V. So this proves 2. Okay, very easy. That is just using definition of projection. Okay. We have a definition here of what is a projection. So here, for a given vector and plane, the sum of projection and rejection is equal to the original vector. So, unsay pasabot ana? The sum, mao ni ang imong original vector, the sum of projection and rejection. So, the sum of projection kana siya. Ang rejection is in B perp, no? So, for a given vector and plane, the sum of projection and rejection is equal to the original vector. The rejection of a vector from a plane is its orthogonal projection. Kini. So this is your rejection and this is your projection. So the rejection of a vector from a plane is its orthogonal projection on a straight line which is orthogonal to that plane. So I've given this definition so that we can use that here in this proof, no? So it is a known fact that the original vector y is equal to the projection of y onto v plus the rejection vector. The rejection vector is the projection of y onto v perp. Or actually, that can be obtained from here. Okay. From here. Here you can see that y is equal to the projection of y onto v plus the projection of y onto v perp. Okay. So if we make this in English form, mo na ang definition 2.18. Okay. So to show this, we will use the result result D1, no? 2.5 D1. So, or theorem 2.5 D1. So that is, you can write, we have shown there that the projection of y onto v perp is equal to y minus the projection of y onto v. Okay? So that, rearranging the terms, you have y equal to the projection of y onto v plus the projection of y onto v perp. And then you get the square norm of both sides. Okay? And then what happened? So mura na siya a plus b square, which is equal to dapat na siya 2, no? A square 2ab b square vectors. Pero kanang 2 din mo na siya mo apply ang inner product. Kasi ang inner product is b prime v or u prime v or v prime u. Okay? So this is this term and this term, square norm. But this is just 0. Why? Because this is an element of V and this is an element of B perp. So there are vectors which are orthogonal to each other. So the inner product is 0. Okay. So what remains is this one and the result follows. Okay. Next. We have a subset of the subspace V, which is W. Subset siya. And this equality is true. The projection of Y onto W. So kung na ako'y subspace na V, ang space na W subset lang ani, no? Na ako'y subspace na W. So kung katong nabilong din na projection is the projection of the projection of Y onto W onto V. So kining projection din PWY na ako'y Y din ang projection niya is actually ang projection ani onto V. No? The projection onto V. Or it is na ako'y Y, na ako'y dako na vector din which is the projection of Y onto V. Kining gamay is actually the projection ani, kining dako, onto the subspace W. So, kaya naman siya sabi, posible na siya mas dako. Pero, kining projection of Y onto W is just the projection aning dako na vector sa subspace na W. Okay? So, all of these are talking about projection. So, ang primero nato ipakita kini, we first show that kini na vector. So, mura siya, tawagon na ako W ha. Kana na vector W is the projection of Y onto V. Kini, of W onto V. Kining W is, kana siya, is actually the projection of W onto V. Okay. So kung projection siya, kini concentrate ani. Kung kini na vector, projection siya of Y onto V, duwa atong ipakita. 1, sa atong ipakita. Dapat PWY is in V projection man. And then Y minus PWY is in B perp. Okay, note that the projection of Y and to W is in W, which is a subset of V, which implies that that is in V. So, mana ni? And then, the projection also is in V. Okay, correct. Then, by theorem 2.5c, the projection of Y, the projection of this vector onto V is just the projection of Y onto W. Let's check theorem 2.5c. Hara. Kung ang Y daw nasa V, then ang projection sa Y onto V is actually your Y. Okay? So, ang atong ipakita din ang atong W or ang atong projection of Y ang atong ipakita din na atong projection of kini na vector onto V is in V. So, ibig sabihin, kini Y is in V. Pero ang atong Y na ginapasabutan ni kining projection of Y onto W. So, equal sila. Ang giingon din if Y is in V, then Y is actually equal to the projection of Y onto V. So, the projection of Y onto V is in V, so that this projection is in V. So, ang projection is in V, which is Y. So, ibig sabihin, kining projection of Y onto W is just equal to the projection. Bali, mauna na si Y. Kining si Y nato, mauna sa projection of Y onto W is actually equal to the projection of, mauna si projection of Y onto W onto V. So, this is what it is saying. Okay? So, kung imong i-relate sa theorem 2.5c, ang imong Y dito, si projection of Y onto W, manani siya sa V. Kung na daw na siya sa V, si Y equal lang sa projection of Y onto V. So, ibig sabihin, ang imuhang PWY is equal to the projection of PWY. Okay? Muna siya. So, change of notation will able to guide you how to use this theorem. Okay? Next. We prove kininapod na kininapod na equality. Kinina po na equality kana is equal to this. So if A is equal to B and A is equal to C, this implies that B is equal to C. No? Okay, so kana lang duha ang atong ipakita. So, sufficient na para anang tulo kas equality there. Okay. Next, we prove this. So projection siya. Projection of this onto W. Kinina vector na pod. So X, na to para sa yun. X is the projection of Z unto W. So kung projection si X, duha atong ipakita, dapat si X is in W or equal man na sila kanang gisulat og Y minus X is in W perp. Okay, si projection of W and the projection of Y unto W na siya sa W. So dapat ang Y minus kana na vector, kini atong vector, kana tanan atong vector is in W perp. So duha atong ipakita. Kini na vector kay projection man siya. Naa sa W, kini na vector nato kay projection siya. Kini projection siya unto W is nasa W and kana siya is nasa W perp. Okay. So let's label U as that para sa yun. Sa ako ang label mo nang si X. Okay, kini na atong gamiton kay mao na sa notes. Okay, clearly kay projection man siya si U unto W, nagi na siya sa W. So wala tay problema ana. Ang atong problema kining second term, no? Okay. So to show that kay naa siya sa W perp, mamili ta og vector na nasa W. Mankuhaw nato ng inner product nila. Ato ipakita kung 0. So kung kini naa sa W, mo follow na kini naa sa W perp. Okay, so doing the same thing as earlier, na ako'y proof na similar ani. Okay. So this one. What happened here? Add and subtract. Okay. Function of ano man siya? Function man siya of kini. So add and subtract, plus minus. And then groupings. One is this, the other one is this. And then distribute that. Okay, so why is this 0 now? Let me enlarge. Okay. So asa ganin ni? This is in W. Correct? Kini asa man ni? Y minus the projection of Y unto V. Where is that? This is in W. Okay. Kini asa ni? Projection of Y unto V. Na siya sa V. And then Kwaon nimo the projection of y unto w. Asa ni siya? Nani siya sa w. So any vector in V minus its projection. Asa na ni siya na vector? So ato ni i-determine nganong zero ni class. Okay, W is in W. But it is a subset of V. So ibig sabihin, W is also in V. Asa ni? Y minus the projection of Y unto V. Asa ni siya? Nani siya sa B perp by definition of projection, di ba? So, kining primero na inner product, kini siya nasa W, pero tungod kay subset sa V, naapon ni siya sa V, kini, klaro man ni siya na naa sa B perp. So, naa siya sa B perp, naa siya sa V, so zero ni siya. Okay? So, it follows that this is zero. Eh, wa may gusto maningog, ako na rin tingog. Kini nasa W, kini, nganong naman na siya sa W perp. Nganong naman ni sa W perp. Asa ni siya? Nani siya sa, kini siya, mura man ni siya katuklas. Mura na siya vector. Murag idilang ni ninyo na vector ni siya as a whole. Kini x man minus the projection of x unto w. No? So, ibig sabihin si x nasa sa w, tang nato, kay vector man siya. And then, ang y, ato bang definition sa projection? Naa kay V, naa sa V, naa kay Y minus V, naa sa B perp. So, ang inyong i-deal din mao ni si V, si X. So, si X nasa W, si Y minus the projection of X unto W is in W perp. Okay? So, ang primero na inner product is with respect to a V and in B perp. Ang second na inner product is in relation to W and in W perp. Still, it is equal to 0. Hence, sa mani napakita na si U minus V nasa W perp. Okay, si W naman sa W. It means that this one is in W perp. So, we showed here that really this vector x is the projection of y unto v unto w. Okay, projection man siya. Projection is siya. Kanang y unto w. Okay? So this statement here, when we rewrite our in terms of projection, equivalent ra ni sila. So ang projection sa y unto w is the projection of Is the projection of y onto w onto v, or it is the projection of y onto v onto w. No? So the same vectors na siya actually. Okay, so na may maningog na po. Undang na po tayo. Questions? Pati pautana, di po maningog. Good luck na tong tanan. Pila man eh. Taghan absent. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Si Maaghop. Maaghop is not around. Okay. Question?
Wala ra, ma'am.
Okay, there's a 90% chance that this coming Monday is a holiday, Muslim holiday. Although there is wala pa yung memo.